I welcome all of you to the chemistry class on date 7th January 2021. We have now enough students to start the class now. So let's start the class discussion, my dear students. Dear student, let us see the class and let's move forward to understand. Okay, so now in the last period, my dear student, we have studied about how the ions are formed, especially the cations. आपको याद है बच्चों? Do you remember that in the last period we have studied about the formation of ions? Do you remember it well? बच्चों आपको याद है क्या? आप लोग मुझे सुन पा रहे हैं डियर स्टूडेंट्स की सुन भी नहीं पा रहे हैं? सुनाई दे रहा है ना? ये तो नहीं है कि आप लोग को कुछ सुनाई ही नहीं दे रहा है मैं जो बोल रहा हूँ वो? You need to give me answer. Do you remember? Okay. So in the last period we have seen that we can form ions. The ions can be formed by either the accepting or the releasing the electrons. So when an atom loses electron, my dear students, when an atom loses electrons, we get cation, but when an atom gains electron, we get anions. So dear students, we want to study now the formation, or we have studied yesterday the formation of cation. So let us do the revision how the cations are formed. So here I am going to explain you when an atom become an ion. So this is what it is written over here, that when an atom become ion, when an atom either lose or gain electrons, atom becomes ions. When an atom become cation, and why? When an atom possesses less than 4 electron in its outermost shell, please remember that generally those ions which forms those atoms which forms cation, those have valence electron less than 4 or equal to 4, but generally less than 4. So these cations are formed by the elements or atoms, those have the valence electron less than 4. So when we have the less than 4 valence electron, my dear student, what happens? We get this cation. So when an atom possesses less than 4 electrons in its outermost shell, when an atom possesses less than 4 electrons in its outermost shell, which is known as the valence shell, it loses its electrons and achieve octet in the outermost shell. Thus, it makes cation. Now, here it is also important that the atom must achieve the octet in its outermost shell. Achieve octet means it should have 8 electrons in the outermost shell. In outermost shell, my dear students, it is very much important that the element must have 8 electrons in its outermost shell. So you can see here, we have discussed some of the example. Let us revise them. This sodium, which has electronic configuration 281, it loses its 1 electron. That means it loses this electron, which is 1, and turns out to be 28. Now, as it loses 1 electron, initially it has 11 electron, but now it has 10 electron. it has initially 11 proton, now it still have 11 proton. We know that, my dear student, for any element or for any species, charge is equal to charge is equal to number of protons minus number of electrons. Please remember that charge is equal to number of protons minus number of electrons. Here in this species, when sodium loses its one electron, the number of proton is equal to 11, the number of electron is equal to 10, and thus 10 minus 11 is plus 1, and that is why we have put plus 1 charge on the sodium. So my dear student, when sodium make plus 1 ion, when sodium make plus 1 ion, you can see that when sodium makes plus 1 ion, it loses its one electron, and when it loses its one electron, my dear students, it actually forms the when it loses one electron, it actually forms the Na plus 1 ion. So by losing one electron, my dear student, the plus 1 charge is being obtained. So this is how we get the charges. Same way when we look into the magnesium, my dear students, here you can study about the magnesium. I'll bring the magnesium to your screen in a very nice manner. Now you can see the magnesium one very nicely. So you can see the case of magnesium on your screen, my dear student. When you look into the magnesium, you can see that magnesium has got electronic configuration 282. So to get the 8 electron in its valence shell, magnesium has to either get 6 electron. So if it gains 6 electron, it becomes 2 plus 6 is equal to 8. Or it can lose 2 electron, and you can see these electrons are being removed. So what magnesium prefers? Magnesium prefers to lose 2 electrons. So initially when magnesium was an atom, it has 12 proton and 12 electron because it is electrically neutral. So when magnesium is neutral, my dear student, when magnesium is neutral, you can see it has 12 proton and 12 electron. But now magnesium prefers to lose its 2 electron. So magnesium loses 2 electron. So now magnesium becomes something, as it loses 2 electron, the new electronic configuration is 2,8. So you can see here that the octet is being achieved. As this octet is achieved, my dear student, we can say that this magnesium has got 8 electron in its outermost shell. Now as magnesium has got 8 electron in its outermost shell, my dear student, you can see that octet is achieved. Here you can see that octet is achieved. Now when magnesium loses its 2 electron in new situation, the total number of proton is equal to 12, but total number of electron is 10. 8 plus 2 is equal to 10. So the charge we can calculate, my dear students, that the charge here, if we look into this, that we know that charge is equal to what? Can you tell me the formula to calculate charge, dear students? What is the formula to calculate charge?
Proton minus electron.
Proton minus electron.
Very good. So to calculate the charge, my dear students, we can write it here as we can write for the charge, dear student, that charge is equal to, just 1 minute. Sorry, dear students. Now we can write the charge is equal to. So we were studying about the magnesium actually, and we can write for the magnesium. As you can see here, for magnesium, my dear students, the number of proton, for magnesium we can write that the charge is equal to number of protons minus number of electrons. Number of proton is 12, number of electron is 10, so we get plus 2. Here you can see that this calculation I have even shown it to you here, that plus 12 minus 10 is equal to plus 2, and that is why we write magnesium plus 2 ion here. So whenever we study this, my dear students, we need to understand that we will have to use this charge on the species when the cation is formed. So whenever the cation is formed, my dear student, we can use this idea and we can have our species formed. I think I'm getting into trouble. So now, my dear students, let us study the next one. The next one that we have is aluminium. Aluminium has got electronic configuration 283. When we have this electronic configuration 283 to achieve the octet, my dear students, we have two options. To achieve octet, we have very few options. Let us look into those options, my dear students. To achieve octet, here we can lose 3 electron. We can lose 3 electron, or we can gain 5 electron. Now, my dear students, I would like to ask you, which one is easy? Is it easy to gain electron, or it is easy to lose 3 electron? Losing 3 electron is easy, or gaining 5 electron is easy? Dear students,
losing
yes,
three.
see, losing 3 electron will be easy as compared to gaining 5 electrons. So that is why aluminium choose to lose this 3 electron, and as this aluminium loses the electron, it become a cation. So we know that whenever something loses the electron, it become cation. So when this aluminium loses its electron, it become cation, and when this aluminium loses its electron, it simply becomes cation. So when this aluminum loses its 3 electron, what happens? Let us see. This aluminum loses its 3 electron. So these 3 electrons are being removed, and the new electronic configuration is 28. So now the new number of electron is 10, but protons are still 13. As there were, because protons have not been changed, so protons are 13, and that is why, my dear students, the charge is equal to number of protons, the charge is equal to number of protons minus number of electron. Number of proton is 13, number of electron is 10, and that is why plus 3 charge is generated on aluminium. Now let us understand the last example for the formation, last two example for the formation of cation. You can see that we have potassium. Potassium has got 19 proton and 19 electron, and its electronic configuration is 2881. Now to obtain the octet, either one electron is being lost or we need 7 electron. But instead of gaining the 7 electron, potassium prefers to lose 1 electron. When potassium loses its 1 electron, the new electronic configuration is 288. So now you can see that the octet is achieved. The octet is achieved, my dear students? So we have this octet achieved here. As this octet is being achieved, my dear student, we can have this 288 electronic configuration. Now what happens when we have this 288 electronic configuration? The number of electron has been decreased. So initially there were uh, 19 electrons. Now we have only 18 electrons. And initially there were 19 protons. The protons are still same. So we have total 19 protons and 18 electrons. We know that charge is equal to protons minus electrons. The number of proton, my dear student, here, the number of proton is equal to 19, the number of electron is equal to 18, and that is how we get plus 1 answer. And that is why on the potassium we put plus 1 charge. Same way, my dear students, if you look into the case of the calcium here, you will come to know that in case of the calcium, the electronic configuration, when our calcium is neutral, we have 20 proton and 20 electron. But calcium, if we want to achieve the octet, either it requires 6 electron to be added or it requires 2 electrons to be removed. So my dear students, in this case, if you really look at, you will come to know that it is easy to remove 2 electrons, and that is why calcium prefers to remove 2 electrons, my dear students. As this calcium prefers to remove 2 electrons, it loses its 2 electron and make a cation. Now when these 2 electrons are being lost, so the new electronic configuration, when these 2 electrons are being lost, my dear students, when these 2 electrons are lost, the new electronic configuration which is formed is 288, because out of this 2882, these 2 electrons are lost and the new electronic configuration is 288. Now you can see that the total number of electron is 2 plus 8, 10 plus 8, 18. So total we have 18 electrons, but we have not changed any protons. So protons are till 20. Now my dear students, we need to calculate the charge, and to calculate the charge we have formula, my dear students, that charge is equal to number of protons plus, sorry, not plus, but it's minus number of protons minus number of electrons. So here, my dear student, we write the number of protons here we write the number of protons, my dear student, and plus number of electrons. So when we look at this, number of protons minus number of electron, number of proton is 20. You can see here that the number of proton is 20 and number of electron is 8288. So the number of electron is 18. So there are plus 2 charge that we have to write on the calcium, and thus calcium loses its 2 electron to make plus 2 ion. So now, my dear students, if we really want to understand everything at a time, we can easily understand it very nicely. So let's look at the whatever we have understand. Let us take a small revision for all this. You can see that we have studied all this for the various ions like sodium, magnesium, aluminum, potassium and calcium. So let us do a small thing that we can have. Okay, so now we'll write it, my dear students, that see, we have started studying about sodium. So when it comes to sodium, my dear student, when it comes to sodium, sodium loses its 1 electron. When it comes to sodium, my dear students, sodium loses its 1 electron. Let us study it here. When it comes to sodium, my dear students, sodium loses its 1 electron and make Na plus 1 ion. So initial concentration was 281, turns out to be 28. Same way, if you look into the magnesium, the the electronic configuration, not initial concentration, I am sorry, its electronic configuration was 281, which turns out to be 28. Magnesium 282 loses its 2 electrons, so these 2 electrons are lost, and then magnesium 28 electronic configuration is formed, and magnesium get +2 charge. Same way, my dear students, aluminium, which is having the electronic configuration 283, it loses its 2 electrons from the valence shell and it forms the Al+3 ion. Same way, my dear students, if you look into the potassium, which was 2881, it loses its 1 electron from its valence shell and then it forms the K+1 ion with the new electronic configuration 288. Then, my dear students, we have calcium. Calcium has the electronic configuration 2882. Here calcium loses its 2 electron and form Ca+2. And the new electronic configuration is 288. So, my dear students, whenever it happens, it actually happens in such a way that you can see that when you have 1 electron in the outermost shell, the element loses 1 electron. When magnesium has 2 electron in outermost shell, it loses 2 electron. When aluminum has 3 electron in outermost shell, it loses 3 electron. When potassium has got 1 electron in the outermost shell, it loses 1 electron. When calcium has got 2 electron in outermost shell, it loses 2 electron. So the number, but remember that the number of valence electron should be less than 4. So when the number of valence electron is less than 4, the same number of valence electron are being lost, and thus we get the cation form. If 1 electron is lost, +1 charge. If 2 electrons are lost, +2 charge. If 3 electrons are lost, +3 charge. You can see when 1 electron lost, +1 charge. When 2 electron lost, +2 charge. So this is how the charges are being formed. Same way, my dear students, if you look into the electronic configuration even, you will come to know that these 2 electrons are lost. So this 28 is formed. Here 3 electrons are lost. So you can see that 28 is formed. Here 1 electron is lost. So 28 is formed. Here 1 electron is lost. So 288 is formed. And here 2 electrons are lost. So 288 are formed. You can see that in all these cases, my dear students, the octet is achieved. Please remember, my dear students, that in all these cases, my dear students, the octet has to be achieved, and the octet is achieved, my dear students. So whenever the cation is formed, the octet is achieved. So please understand, my dear students, this is how the cations are formed. Now let's move forward and understand the formation of the anions. Dear students, let us study the formation of the anions first. So now let us move and understand the formation of the anions here. So when it comes to the formation of the anions, dear students, can you see the screen? बच्चों, क्या आपको स्क्रीन दिख रही है?
Yes, sir.
Yes.
Very good. So let us understand the formation of the anion now. We will understand the formation of the anion. Let us understand the formation of the anions. Now please look into this. I have even shown you this with the when an atom loses its when an atom loses its electron, it does not lose its proton. Please remember. So number of proton is more than the number of electron, and thus the atom get positive charge. That you can understand here. So here you can see, my dear student, that you have sodium. This sodium has got electronic configuration 281. So in the first cell you have two electron. In the second cell 1, 2, 3, 4, 5, 6, 7 and 8 electrons. And in the valence shell, or which is the outermost shell, we have 1 electron. This electron is lost by sodium. So this electron, you can see that this electron is lost by sodium which we have represented over here, and then the proton are not lost. So in the nucleus we have 11 proton and 11 proton, but the electron become 10 now. So now the number of electron become 10, 2 plus 8, that is 10. And the proton are still 11, and we know that charge is equal to number of protons minus number of electrons. So number of proton minus number of electron. Number of proton is 11. You can see here the number of proton is 11. Number of electron is 10, and that is why it possesses plus 1 charge. So this is how, my dear student, we understand about the formation of charges into an ion. Now let us understand when an atom become an ion. So let us study about when an atom become an ion and why. When an atom possesses more than 4 electrons in its valence shell, the basic condition is the atom must possess more than 4 electrons in its valence shell. To achieve octet, it gains electron and make anions. So when an atom gains electron, it makes an ion. You can see that this Cl287, 1 electron it gains, and this 7 plus 1 become 8 and it becomes Cl minus 1. Same way oxygen 2,6, it gains 2 electron. So 2,6 become 2,8, my dear student, and it turns out to be minus 2 ions. Same way nitrogen, it gains 3 electron. So initially there were 5 plus 2, 7 electron, but as this 5 plus 3 become 8, n minus 3 is produced and the electron become 10. Now let us understand why this electron which are added, they make change into the charge. So here, my dear students, you can easily understand that the formula to calculate charge, so we have charge is equal to number of proton minus number of electron. Whenever you want to discuss the charge, we will use this formula. So here the number of proton in chlorine is 17, but the number of electron now had become 2 plus 8, 10, plus 8, 18. So it is minus 1. So plus number of proton is 17, number of electron is 18. Proton minus electron, that is 17 minus 18 is minus 1. And that is why we have minus 1 charge on chlorine. Same way, my dear students, when we think about oxygen, initially it has 8 electron, 6 plus 2, 8 electron, but as it gains 2 electron, the number of electron become 10. We know that charge is equal to number of proton minus number of electron. Still the proton are 10, proton are 8, electron are 10, so 8 minus 10 is minus 2, and that is why our oxygen get minus 2 charge. Same way, my dear students, when we look at nitrogen, nitrogen gains 3 electron. So the electronic configuration, which was 2,5, turns out to be 2,8. Octet is being achieved. You can see that the octet is achieved. But the charges, if you think that the charge is equal to number of proton minus number of electron, protons are 7, electron are 10. So 7 minus 10, that is minus 3, and that is why we put negative charge on nitrogen. Same way, my dear students, if we understand the other examples, if we think about fluorine, the electronic configuration is 2,7. To achieve octet, my dear students, this fluorine gains 1 electron and becomes 2,8. So here the number of proton is 9, but the number of electron is 10. So my dear students, the charge is equal to number of proton, that is 9, and number of electron is 10. So it is 9 minus 10, which is minus 1, and that is why we write minus 1 charge on fluorine. Same way, my dear students, if we look at the sulfur 286, to achieve the octet, this sulfur gains 2 electron and make octet complete. So now the new electronic configuration is 288. Octet has been achieved, but the number of electron has been increased from 16 to 18. So now if we calculate the charge, my dear student, the charge is equal to number of protons minus number of electron. Number of proton is 16, number of electron is 18, and thus minus 2 charge can be written on sulfur. So this is how, my dear students, we can understand the formation of the anion. You can see with this figure also that when an atom gains electron, my dear students, number of protons remains the same. Thus negative charge become more and number of electron become more than the number of proton, and thus the negative charge is generated on anion. Now let us understand this with the example. If you look at the example of chlorine, my dear students, chlorine has the electronic configuration 287. So when chlorine has the electronic configuration 287, my dear students, you can see that first has 2 electron, then K shell has 2 electron, L shell has 8 electron, and M shell has got 7 electrons. See, 1, 2, 3, 4, 5, 6 and 7 electrons are available. So this chlorine gain 1 electron and it makes 8 electron in its outermost shell. 1, 2, 3, 4, 5, 6, 7 and 8 electrons are now available. So the electronic configuration now is 288, my dear students. And as this electronic configuration turns out to be 288, this octet is achieved. Octet is complete. Now you can see that if we want to calculate the charge is equal to number of protons minus number of electron. Number of proton is 17, that you can see inside the nucleus, but the number of electron is 2 plus 8, 10 plus 8, 18. So it is minus 18 and 17 minus 18 is minus 1, and that is why we show negative charge on chlorine. So this is how, my dear students, the negative ions are being formed, and these negative ions are formed by gaining of electron. So let us try to understand it by some other means, my dear students, that when we have, my dear students, when we have ions like fluorine, the electronic configuration is 2, 7, it gains 1 electron and it becomes F minus 1. And the new electronic configuration is 2, 8 because octative achieves. Same way, my dear students, if you look into the oxygen, the electronic configuration is 2, 6, it gains 2 electron and it becomes O minus 2. The octet is achieved by gaining 2 electron and the new electronic configuration is 2, 8. Same way, my dear students, if you look into the nitrogen, the electronic configuration is 2, 5. To achieve the octet, the nitrogen gains 3 electron and it becomes N minus 3 because 3 electrons are gained and the number of electron become more than the number of proton, and here the new electronic configuration is 2, 8 and again the octet is achieved. If you look into the chlorine, my dear students, the electronic configuration is 287. Chlorine gains 1 electron and it becomes Cl minus 1. The octet is achieved by obtaining 1 electron, and this 7 plus 1 become 8 electrons. Same way, if you look into the sulfur, my dear students, it is the electronic configuration is 2.